Welcome to PaperCam Wave of the Future. So, special triangles, these things 45, 45, 90, and 30, 60, 90. Sometimes they come in handy, sometimes you need to know them for whatever reason, but maybe you don't remember. So, let's see if we can cook up the rules just from basically scratch or a few randomly remembered geometry facts. So, when you see this, you have two angles that are the same. You should remember, oh, two angles that are the same, isosceles triangle. It's in a weird orientation here, but if I write it like this, 45, 45, then, oh yeah, there it is, isosceles, and that tells us that these sides are the same. Alright, so let's just decide that these sides equal 1, or we say, if those sides equal 1, supposing they're 1, what does this side equal? So we use the fact that it's isosceles to make these the same, and then look, it's a right triangle, and most of us have had the Pythagorean theorem drilled into us so well that it might as well be tattooed on the inside of your eyeballs. There it is. So this, we know these two, we know the legs, we don't know the hypotenuse. So let's work it out. 1 squared plus 1 squared equals something that I don't know what it is. I'm trying to find out. 1 squared is 1 plus 1 squared. It's 2 equals, we still don't know. But we're trying to get this question mark so we can take the square root of both sides. And so then we get question mark equals 2. So that, oops, I did something weird there, didn't I? Question mark equals square root of 2. Sorry. So this square root here got rid of the squaring because it was question mark squared. What's the square root of question mark squared? Well, that's question mark. And then square root of 2, I'm just writing it over here. So this is radical 2. And that's your rule for 45, 45, 90. Whatever value is here, you multiply it by radical 2. There's like a 1 hiding here. Alright, let's look at good old 30, 60, 90. I'm going to draw a little bigger, pull it down here. So, looking at this, I kind of wish there was some isosceles-ness going on over here, but there's not. So what I'm going to do is make some. I will just make a mirror image of this thing. We're just playing around. So this would be 30, and this would be 60. And now, this is nice because we don't just have isosceles, we have equilateral. Because look, 60, 60, 60. So that means this is equal to this is equal to this. All three sides are equal. And, bonus, because this is a mirror image, this is half, this is half of this thing, and this is half of this thing. These are equal. So I know if I call this 1, then this will be 1/2, and this will be 1/2. I don't, however, know what this is. So, I'm going to go back to my old Pythagorean theorem. We're going to label this C, and this will be A, and this will be B. So I have 1/2 squared, that's my A, plus something we don't know what it is, we'll call it B this time, squared equals 1. squared. Now we can solve for this. So 1/2 squared, that's 1/2 times 1/2, so that'll be 1/4 plus b squared equals 1. 1 times 1 is 1. We'll subtract 1/4 from both sides. We'll get b squared equals 3/4. Now I want to find out what b is, so it's squared. I'm going to take the square root of both sides. So this will be b. And then b will equal square root of 3/4. Now I can do this old trick. You don't have to, but I'm going to, just so it'll look the way you're used to it. And then this square root of 4 is 2. Radical 3 over 2. B equals radical 3 over 2. So let's just make it nice. We get 1. We get 1/2. We get radical 3 over 2. So you might be looking at this and be like, this doesn't look like how it looks in the book or whatever. Well, if you look at it, we could say, well, what times this gives you this? Well, that would be 2, right? So we're going to play a game where we just see, like, how do I get from here to there? So if I want to get from here to here, I multiply by 2. If I want to get from here to here, what do? I multiply by radical 3. So if this one was 1 on the bottom, then I know, well, it would be 1 times 2 to get that. And if this one was 1 and I want to get that one, well, that would be radical 3 times it. And now this is how you're used to seeing it. And that's how you derive the rules for special triangles. Kind of from scratch, not entirely, but from stuff that if you get there, if you know these exist, then you probably have been drilled in those other things enough, just isosceles and Pythagorean theorem, well enough that you would be able to cook this up. Try it on your own sometime.